is a good reason Varel Energy Solutions uses the word Everest to brand their line of large diameter roller bearing products. We picked up the manufacturing process in the turning center at their facility in Matamoros, Mexico.
This is a vertical turning lathe that turns all the surfaces within a 2,000ths tolerance. You can see the difference in the surface finish of the prelim versus the finish back there. So this cell here is basically cutting the journal bearing portion of the jumbo heads. These machines sets us apart from any other roller cone manufacturer, that they can't do these sizes from 36-inch up to 45-inch like we do. What you're looking at now is it's a TCI bit. It's being back-faced and it's being prelim. One side of the Kuma will turn the bore and then it flips around, and the other side cuts the profile. Dual spindle machine gives us better capacity. So these are 32-inch finished cones, and the prelim bore will be turned on the inside. So the cone's going to be raised up above the fixture and then actually going to be turned upside down so that the bore is exposed so the VTL can turn it after the fixture is assembled. This is just one of the steps of our total quality plan throughout our entire manufacturing process. So he's building on certain datums on the actual piece part to let the software know whenever he takes measurements from those datums, they can provide the correct dimensions for us. As you'll see on the screen, you can see the datum starting to kind of come in place a little bit, and the geometry is being created every time that he starts to digitize on the cylinder right now. So we're now in the heat treat facility. What you're seeing here is the painting with no carb paint prior to going into the ovens. So anywhere that you will see the paint, there will be no carburization done to the steel where the paint is. So only the steel that is exposed without the paint will take the carburization of the casing, which is formulated from temperature, cycle time, quenching, and everything to get the right casing inside of our bearings for durability and longevity of the bit life. You can see the whole outside is painted off with no carburization, and if you look inside, you'll see that the parts that are left open will accept the casing, of course. These will be loaded up here in a minute and put into one of the furnaces. Some of our furnaces quench and temper. We have 8 of them. These will heat treat our small to medium size parts for the bits. So this is 2 of our 4 pit furnaces. This is where more of our larger parts get done. They get carburized, heat treated here, and then they get pulled out to be quenched. So what we're watching is hard facing, which is stellite material, being put onto the journal pad, the thrust face, and the pilot pin. This creates a hard journal for our running process. Right now he's preheating to lay the hard facing in. And right behind us, we're setting up with the robotic of the actual hard facing coming down, being welded on to make a top quality hard facing surface for our bearings. So this is yet another quality control point inside of our process where the depth and the diameter is being pneumatically checked and marked appropriately to see if everything is within tolerance. Depth and the diameter is very important with the interference with the carbide insert. So we're entering our carbide plant. We buy our own powder and we make our own carbide inserts themselves. So these are new additions to our carbide plant. These are completely automated, robotic. This is a dual die, so it's making them. And there is a small QC process right here that is actually weighing each insert as it comes out to verify that it was made correctly. This has increased our capacity and has increased the quality of the inserts that we make. Every one of them, after being sintered and high energy tumbled, is quality inspected. Every one is brought out, weighed, measured, fit exactly. He's got his micrometer, inspection tools. He's got a full report to fill out for every insert. So this is the insert pressing operation. It is done with a guide pin that the operator will slide into the hole to line up the press itself so that it's not off center. These guide pins are made from tool steel and they're regularly maintenanced and changed out. Below it is a copper shim, which helps whenever you press the insert in, fill some of the voids at the bottom. The machine can index to be perpendicular to any one of the rows so that the guide pin is perpendicular with the hole's axis. For our Everest product line, we have matched where each cone is matched for a head itself. So you can see it from over here. We go from the bit thirds with the heads and cones to the fixture of being put together, loaded up, and they'll be sent over to welding. So we're watching the bit be moved over to the welding process right now. We got to gauge the bit. They'll start tacking it, then they'll fully seam weld on the outside, on the dome, and down on the inside of the bit as well. So this is the turning centers we have in assembly. It's one of the machines we use to thread our bits. We use 3 dimples on the head to get the bit on center, and then we completely turn the threads. We can thread all the way up to the 36-inch bit with these machines. Again, another machine that sets us apart. This gives us the capability to thread up to a 45-inch bit.